Hi there, everybody, and welcome back. We're looking at question 5 on the Manitoba Math Contest from 2017. It's got two parts here. 5A. Both digits of a two-digit number k written in standard notation are non-zero. Okay. When their order is reversed, the new number is 45 less than k. Find all possible values for k. All right. So it's a two-digit number, and we are singling out the individual digits and then doing something, namely reversing them. So I'm going to start by saying, let k be written as 10a plus b. Then we're going to have certain things like 0 is less than both a and b, less than or equal to 9. Now, reversing the digits gives 10b plus a. 45 is their difference. And I think it was k minus the reversed order, but let's double check that before we keep going. 45 less than k, all right. But now, 10a minus a, we get 9a, and then b minus 10b, we get minus 9b. We get 9 times a minus b. Dividing by 9 on both sides, we see 5 is a minus b. So I'd make a very quick chart. B can be 1, 2, 3, 4, 5, 6, 7, 8, 9. What would A then be? And then therefore what would K be? So A would be 5 more than that. A would be 6, 7, 8, 9, 10. No more of this will work. So K could be 61, 72, 83, or 94. If we wanted to, we could check one at random. 83 minus 38. Bring the 1 over. 13 minus 8 is 5. 7 minus 3 is 4. Okay. So here are our possible values. So K can be 61, 72, 83, or 94. 4 different values for K. Alright, so B part. N is an integer strictly between 1,000 and 10,000, so it's going to have 4 digits. So I'm thinking already, before even seeing more of this, that I'm going to write something as 1,000 times A plus 100 times B plus 10 times C plus D. Just thinking about it that way. Okay, but let's get back to the question. Reversing the digits of n gives a number m, also strictly between these. Okay. Furthermore, both m and n are divisible by 45. Find all possible values for n. Oh, that's interesting. So we're not subtracting anything. Okay. So new sheet of paper. Let n equal 1000a plus 100b plus 10c plus d, and I'm going to choose to just sort of write that as a, b, c, d. M is then 1000d plus 100c plus 10b plus a, or we could write d, c, b, a. Now since 1000 is less than both m and n, we see a and d are not 0. Okay, a can't be 0, otherwise n would just be in the hundreds, and d can't be 0, otherwise m would be less than 1,000. It would be somewhere in the hundreds. All right, so a and d aren't 0, and then both of the numbers are divisible by 45. So what does it mean to be divisible by 45? Well, we have to sort of remember our divisibility rules. Now, 45 I can write as 5 times 9, and both of these have their own divisibility rules. So 45 divides m and n, not m times n, m and n. Because these guys are co-prime, or they're relatively prime, or another way to say it is their GCD is 1. This is true exactly when 5 divides m and n, and 9 divides m and n. So we just need to sort of remember. 5 dividing n means that d has to be either 0 or 5, but d can't be 0 So D is 5. 5 dividing M, what does it mean to be divisible by 5? You have to end in either a 0 or a 5. So A is 0 or 5, but A can't be 0, so that tells us A is 5. So already we know N looks like 5, B, C, 5, and D looks like 5, C, B, 5. So that really narrows a bunch of things down. Now how about divisible by 9? Well, a number is divisible by 9 exactly when the sum of its digits is divisible by 9. And this also covers the M being divisible by 9, because it's just the digits. We don't care about the order or anything like that. With divisibility by 5, we care about the order because we're interested in that last digit. Just like divisibility by 25, we care about the last 2 digits, that sort of thing. Same with divisibility by 4, we care about the last 2 digits. Okay, so we just need A plus B plus C plus D to be divisible by 9. But hey, we know what A and D are. So 9 needs to divide 5 plus B plus C plus 5, or 10 plus B plus C. So subtracting 9 from the 10, we get 9 needs to divide 1 plus B plus C. Okay. Really, that's the only restriction. That's it. We didn't say that they're both distinct numbers. You know, M and N could be the same. Palindromes count. We just need them both to be divisible by 45. Everything else is covered. So, what should we do? Now, both B and C could still be 0. So, B plus C can be anywhere between 0 and 18. And B plus C plus 1 can be anywhere between 1 and 19. To be divisible by 9, we would need to have B plus C plus 1 be equal to either, well, what multiples of 9 are in this range? Either 9 or 18. So B plus C is either 8 or 17. Okay, well, let's make a little chart. So B could be 0, 1, 2, 3, 4. Finish our chart over here. 5, 6, 7, 8, 9. C could be what? Well, if I wanted 8, C could be 8. Let's make it a little more obvious what we're doing here. Got to make the chart readable, otherwise we might not get marks. So C being 8 minus B, or C being 17 minus B. So C could be 8 or C could be 17. Well, no, it can't be 17. 7 or 16? Nope. 6? Yeah, it could be 6. 15? Absolutely not. 15 is not a single digit. That's the problem. C could be 5. C could be 4. And that would give us 17 minus 3 is 14. 13? Nope. 8 minus 5, yeah, 3, sure, but 17 minus 5, 12, no, that's not going to cut it. 11, no. 10, no. Finally, B being 8, C being 9 works out just fine. And B being 9 and C being 8 works out fine, but now C being 8 minus 9 would be negative 1. That also doesn't count. So we can have, we want the values for N. N can be 5, 0, 8, 5, 5, 1, 7, 5, 5, 2, 6, 5, 5, 3, 5, 5, 5, 2, 6, nope, we already did 2, so we're up to 4, 5, 4, 4, 5, 5, 5, 3, 5, 5, 6, 2, 5, 5, 7, 1, 5, 5805, 5895, and finally 5985. So 2, 4, 6, 8, 10, 11 different values. And something you might want to do is pick one at random, let's say 5625, and ask, is that divisible by 45? Well, 45 goes into 56 once, leaving us with 11. Bring down the 2, 90, so it goes in twice. So 90 goes here. Bring down the 2, 225. So 45 goes into that 5 times. And hey, yeah, it worked. And we could even reverse it. But notice that its reverse is also on the list. So M is also on these lists as well. And that's just a nice little double check. If we've got time, we do those little things. But we wanted find all possible values for N. Well, there it is. So that wraps up question 5. Join me in the next video for question number 6. I will see you guys there.